Hello, I'm Rebecca the Maths Lady, and welcome to this video which is all about circles and pie charts. In this video I'm going to explore how we teach children to draw circles and name the parts of circles, and the work we do to help them understand pie charts at this stage of their maths development. Now, you may think that when we're teaching pie charts that's a step on from other bits of data representation, that it follows naturally from our work on bar charts. But in fact, mathematically, it follows better from our work on finding fractions of amounts using a circular representation. So it may be that you've used a linear or a bar representation to help children think about finding fractions of amounts, and you've not actually taught them to see their fractions in circles yet. So if you haven't done that work with your children, you need to find out if they've done it with another teacher further down the school. And if they haven't, you need to do a little bit of foundational work on that before you get going with pie charts. So here's a link to a video that explains that bit of maths teaching. Right, let's get started by talking about drawing circles. So your children are going to have to get used to using a pair of compasses, and that is really difficult because these are hard to use. It takes time to learn the degree of control that you need so that they don't slip. And these are very fallible instruments. If a screw gets too loose, then nobody's going to be able to use them, and that's a really demoralizing experience for a child. So first of all, you need fairly sharp pencils, and they need to be inserted so that the pencil tip touches the spike. And then you need to check that they are going to work before you give them to the children. So check that when you tap them gently, they're not moving. And then when you give children pairs of compasses to use, explain to them that it's like getting used to a new technological device controller. It's just really tricky at first, and you have to try really carefully and not get too frustrated. And that in fact, they might not work very well either. Because what tends to happen if children have a really bad experience with a pair of compasses, then they give up on them and it becomes fixed in their mind that they can't do it. So if you can work through that with them at this stage, that is so helpful. So I would put aside a substantial chunk of a day, an afternoon, for an art project where children can really get going with their pairs of compasses, and it's all about using them. And then you're going to have the time you need to work slowly and carefully with the children who are struggling. And your children who are not struggling so much are going to become really fluent and confident at using them. So they'll be confident in the future, and they'll be able to help the children who struggle more. If you get children who really can't use these types of pairs of compasses, you can get what's called engineering compasses that have a disc in the middle, and then you have more precise control. And if you have a child who just has a meltdown and gives up, then you need to say, don't worry, we need to get you some engineering compasses and you'll be fine. And at least that can be sorted out before they go to secondary school. So there are various art projects you could do. You could get them to do some concentric circles, but the nicest bit of art is where you draw one circle and then you put your pair of compasses on the circumference of the circle and draw another circle, and then you move the point of your compasses to where the two circles intersect, and you put the point of your compasses there and draw another one, and so on. And you develop this beautiful floral pattern. And then within that pattern, you can join things up in different ways and colour them to show the tessellation of hexagons or triangles or just beautiful pictures. And there you can see that 3 hexagons meet at a point. Therefore, the angle in a regular hexagon must be 120 degrees because it's a third of the full turn. And 6 equilateral triangles meet at a point. Therefore, each angle there must be 60 degrees because 6 60s make 360. Lots of maths in that. Explore it, make those connections, and enjoy it. So once children have become able to use a pair of compasses, the next stage is to teach them to name the parts of a circle. The radius is the distance between the point of the pair of compasses and the pencil. And we can do big arm movements, moving your arm around in a full circle to show your arm is the radius of the circle. The diameter is 2 radiuses that go all the way across the circle, so we can show that with our arms. And the circumference is the distance all the way around the outside. We can swing our arms around and imagine that distance. And it's really good to link your work on circumferences back to the measuring work with the trundle wheel, and you can look at the circumference of the trundle wheel being a metre again. It'll deepen and consolidate that learning. Now, these bits of vocabulary are not on the curriculum at this stage, but it's really nice if you as a teacher can use them fluently. If their diameter slips and doesn't go through the centre of the circle, you can say you've drawn a chord instead. Once you've explained the vocabulary of radius, diameter and circumference to your children, you need to drill it until they really know it. Right, let's talk about pie charts. Now, if our children were fluent with calculators, the topic of pie charts is a natural continuation of the topic of bar charts, because it's another way of presenting categorical data. But because we're not using calculators yet, the kinds of pie charts we can work with are very limited. And really we're looking at situations where children can see an angle in a circle and can reasonably puzzle out what fraction of the circle that angle is, and can then reason with fractions. So for example, if we look at this pie chart here, and we said this is a pie chart to show people's favourite colours, and we interviewed 60 people. The kind of questions we're going to be asking are how many people chose blue, how many chose orange, and how many chose red. And we want them to be able to see that that is a quarter of a circle, because that's a right angle. So it's 90 degrees, it's a quarter of a circle. Therefore, we're trying to find a quarter of the total of 60 in this section, so that's 15. Now this section here is 120 degrees. So we want children to be able to puzzle out that 120 degrees is a third of a circle, and then find a third of 60 to go in this section, so that's going to be 20. We had 60 altogether, so we've used 15 and we've used 20. That's 35 used, therefore there must be 25 people left in this section. So we've previously done reasoning with fractions of amounts. The extra step here is making the link between what that angle is and what fraction of a full pie chart it is. Now, once you recognise that that's the detail we're focusing on to nudge children on to being able to reason with pie charts at this stage, you can really drill in on that particular aspect of maths. So we could ask a child about a 72-degree angle. If there was a 72-degree angle in a section of a pie chart, what fraction of the pie chart would that be? And we're precisely zoning in on that little bit of challenge that they've got to say to themselves, well, it's less than a quarter, but I know that a sixth is 60 degrees because I've seen these patterns. I know that a sixth is 60 degrees because I've done that work. So it's bigger than that, so it's between a quarter and a sixth, so maybe it's a fifth, and then they can do 5 lots of 72 and find that they are 360, and they can reassure themselves it's a fifth, and then they're going to be able to work with that pie chart. So it's really worth you working through the different unit fractions they're likely to come across and making sure they've got experience of each angle associated with that unit fraction. So a half being 180 degrees, a third being 120 degrees, a quarter being 90 degrees, a fifth being 72 degrees, a sixth being 60 degrees, an eighth being 45 degrees, a tenth being 36 degrees, and a 12th being 30 degrees. And then it's great if you can also do some non-unit fractions, so they'd need to see that 2/3 were 240 degrees. And the final step with pie charts is that you may get questions where you're not told the total. You may, for example, be told that 12 people chose orange and asked to reason on, therefore, that there were 36 people altogether, and then perhaps find a quarter of 36 to find how many people chose blue, and that it was 9 people. So the topic of pie charts is a really big topic, but because we haven't got calculators, it's about learning to link specific angles with fractions and link up your reasoning with fractions to the visual expression of a pie chart. And I know I should do a worksheet on that at some stage, but the mechanics of creating it are a little bit difficult. If I do one, I'll put a reference to that in the description of this video. So that's it. We've talked about how we teach children to use pairs of compasses and some of the art projects that are so valuable to do because they link together so many aspects of maths. We've talked about teaching children to name the parts of circles, and we've talked about how we teach children to reason with pie charts at this stage of their mathematical development. Thank you so much for watching. If you've got any thoughts or questions or comments, please post a comment in the video. If you've not subscribed to the channel yet, please subscribe so you can find it again. If you could give us a like, that would be fantastic. And if you could share links to this video or this channel with any friends or colleagues that you think might find it useful, that would be hugely valuable. Thank you for taking this time to become a fabulous maths teacher. I hope you'll join me again for another video soon. Bye for now.